China has launched an unprecedented mission to retrieve samples from the far side of the moon.
For decades, the moon was quiet. The dust from Apollo's final descent had long settled. The Soviet lunar program faded into memory. Earth's attention drifted outward, to Mars, to the outer giants, and then to the stars themselves. But now, something has changed. The silence is breaking. The moon is calling again. Not with sound, but with signals, landers, footprints, and questions. And for the first time in over 40 years, we are no longer alone in answering. Because this time, China got there first. Before we dive in, if this kind of in-depth storytelling speaks to you, hit like and subscribe, not because it's trendy, but because these stories are unfolding fast and quietly. It began not with rockets, but with vision. While other nations remained fixated on orbit or Mars, China quietly outlined a methodical roadmap back to our nearest celestial neighbor, not for flags and fame, but for something more enduring: resources, power, and position. In 2007, a spacecraft named Chang'e 1 entered lunar orbit. It carried with it no crew, no rover, no return capsule, just sensors. It mapped the moon in 3 dimensions and scanned the soil from afar. What it found surprised even the mission planners. Traces of an element rare on Earth, but potentially game-changing: helium-3, an isotope formed by solar winds, embedded in lunar dust, and potentially capable of powering fusion reactors without radioactive waste. Chang'e 1 didn't just take pictures. It whispered a question to those listening. Is the moon more than a relic? Could it be a resource? In the decade that followed, China didn't slow down. Chang'e 2 refined the orbital maps. Chang'e 3 made a soft landing, the first in over a generation, deploying the Jade Rabbit rover across the Mare Imbrium. It was a return to the surface, but it wasn't the real goal, because the far side of the moon, the side we never see from Earth, remained untouched. Not by politics, not by culture, but by physics. No nation had ever reached it. No probe had ever landed. There's no direct radio link, no Earth-facing visibility. And so it remained in the dark. Until 2019, a new mission, Chang'e 4, carried a new rover, Yutu-2, and made a landing that many didn't believe would work. The descent was guided through a relay satellite, placed in a gravitationally balanced halo orbit beyond the moon. That satellite, named Chang'e, or Magpie Bridge, created a stable communication link from Earth to the far side for the first time in history. And with it, a soft landing occurred inside the Von Karman crater, a colossal depression nested in the moon's south pole, Aitken Basin, one of the oldest and deepest known impact sites in the solar system. This wasn't just a landing. This was a claim. From that moment, what was once distant myth became active territory. The rover rolled out, cameras activated, sensors engaged. What they saw wasn't just terrain, it was contrast. Unlike the lava-filled basins of the near side, the far side was heavily cratered, thicker in crust, and geologically distinct. Why? That's still debated. Some theories suggest early asymmetry during formation. Others point to the moon's orbital lock, one side always facing Earth, the other shielded. Whatever the cause, this mission wasn't about theory. It was about data. Soon, the anomalies began to emerge. Yutu-2 detected an unusual texture inside a small crater, a glistening, irregular patch unlike surrounding dust. The images weren't released right away. For weeks, speculation ran wild. Volcanic glass? Meteorite melt? Something artificial? Eventually, the photos confirmed a mass of glass-like material, melted rock, possibly enriched with rare minerals, fused by an ancient impact. Not alien, but definitely rare. A geological event locked in time, and now sampled. But Chang'e 4 carried more than geology instruments. It carried life. Inside a small metal biosphere container were seeds, yeast, fruit fly eggs, and 1 cotton seed. In the days following the landing, the container's interior warmed under artificial light. Cameras watched. Soil sensors monitored conditions. And then it happened. The cotton seed sprouted. Under lunar gravity. Under lunar radiation, on lunar soil, a delicate green leaf unfurled inside that sealed chamber. It didn't last long. The lunar night came, and temperatures plunged. But for that brief moment, Earth life grew somewhere else. And that changes everything. From here, the implications accelerated. More Chang'e missions followed. Chang'e 5 returned samples from a different lunar region and brought with it a new mineral, Chang'e Site-Y, which also contained traces of helium-3. China became the third country in history to return lunar rock, and the first to bring any back from the far side. And this was just the beginning. Their program's next steps were already in motion. Landers aimed at the lunar South Pole, rovers equipped for ice detection, and long-term plans for automated construction using 3D printing from regolith. Because if water is found, and it has been, then not just energy, but habitats become possible. And if fusion becomes viable with lunar helium-3 as fuel, then the moon becomes more than a science project. It becomes a keystone for Earth's future. Meanwhile, speculation didn't stop. Photos of strange formations, like a cube-shaped silhouette dubbed the Mystery Hut, triggered internet theories ranging from alien outposts to secret military structures. The hut, it turns out, was just a boulder. Shaped oddly, yes. Mysterious? No. But not all questions faded so easily. China's lunar missions are run by a civilian space agency, yes, but that agency reports to military oversight, which has raised flags in the West. What could a far-side base offer? Radio silence. Shielding from Earth-based interference. A stealth vantage point. The moon's far side is the one place in cislunar space that never sees Earth. And with it, a perfect spot for radio astronomy. Or something more strategic. China insists its goals are scientific. And maybe they are. But it's no accident that nations are now racing toward the same territory and talking openly about permanent lunar presence. The far side is no longer unreachable. It's being mapped, measured, sampled, and above all, prepared. Because the most valuable resources of the 21st century may not lie in Earth's crust or under its oceans. They may sit, untouched, in the dust of lunar basins waiting. Water ice, helium-3, rare earth metals, exotic minerals deposited by ancient impacts, preserved in vacuum, free from erosion. To the public, this is science. To nations, this is positioning. China's space agency, the CNSA, has begun framing its future missions not just as exploration, but as infrastructure development. Their roadmap includes Chang'e 6, which successfully returned the first ever far-side lunar samples, over 2 kilograms of regolith taken by robotic drill and arm. Chang'e 7, scheduled to target the South Pole, the area believed to harbor permanently shadowed craters, where frozen water may exist. And Chang'e 8, the mission designed to begin in situ testing, turning lunar dust into building material, recycling water, and experimenting with automated 3D printing on the moon. These are not stepping stones toward a flag. They're foundation stones toward a base, a permanent presence. China has publicly stated its goal to build a robotic outpost at the lunar South Pole by the early 2030s. But they won't be alone. The United States has revived its ambitions too, through NASA's Artemis program, now backed by private aerospace giants like SpaceX and Blue Origin, along with dozens of allied countries under the Artemis Accords. Artemis 3, the planned mission to land humans at the moon's South Pole, has been delayed but remains the centerpiece of America's return. Meanwhile, China is developing a new heavy-lift rocket, Long March 10th, and a modular lunar lander, both aimed at putting Chinese astronauts on the moon by 2030. The timeline is tight, the territory limited, and the target? The same place. The moon's southern polar region is a strategic gem. Elevated ridgelines receive near-perpetual sunlight, perfect for solar energy. Shadowed craters hide possible water ice, essential for drinking, oxygen, and even rocket fuel. And the terrain, though hostile, offers a rare mix of stability and accessibility. In short, it's the best possible spot to build. And both China and the United States want it. This isn't the Cold War race of the 1960s. No one's trying to beat the other to the flag. But something far more complex is at play now, a race to define the rules. The 1967 Outer Space Treaty forbids any nation from claiming land on the moon. But it says little about extracting resources and nothing about exclusive access to infrastructure. So the questions multiply. Who gets to mine helium-3? Who controls lunar ice? Can nations carve out zones for safety? And if so, are those zones temporary or territorial? What happens if a nation installs sensors, antennas, or defense systems on lunar ridges for peaceful use? There are no clear answers, only momentum. This ambiguity is shaping real policy. The US has drafted the Artemis Accords, a diplomatic framework outlining behavior on the moon, including transparency, safety zones, and peaceful collaboration. So far, dozens of countries have signed on, but not China. Instead, China and Russia have proposed their own project, the International Lunar Research Station, ILRS, inviting other nations to join under a different banner. The result? A bifurcated lunar future. 2 systems. 2 alliances. Headed for the same terrain. But here's the twist. It's not just about Earth-based rivalries anymore, because the moon itself is not passive. It's revealing resources, validating energy concepts, confirming that ice exists in quantities once thought impossible, and most of all, proving that lunar habitation is no longer science fiction. With oxygen, hydrogen, and solar power, humans could live there. With fusion fuel, they could power Earth. And with permanently installed sensors, they could listen to the universe without terrestrial noise, something only possible on the far side, where Earth's radio interference cannot reach. The moon has always pulled at us, but now it may power us. One of the quietest yet most significant findings came from a 2020 analysis of Chang'e 5's soil data. Inside mid-latitude lunar regolith, scientists found hydroxyl signatures, not water, but chemically bound hydrogen and oxygen atoms deposited by solar wind. This suggests that water-like compounds may exist across broader regions than once believed, not just in polar shadows. And if true, then lunar soil is not just dirt. It's potential for water, for air, for fuel, for survival. Helium-3 remains the crown jewel. It's rare on Earth, but the moon, bathed in the sun's stream for billions of years, has captured untold quantities. Just 40 grams, less than the weight of a chocolate bar, could theoretically produce the energy equivalent of 1,500 tons of coal. Estimates suggest over 1 million metric tons of helium-3 might lie within the moon's surface. Enough to power civilization for millennia, cleanly, efficiently, with virtually no radiation risk. There's only one problem. We don't yet know how to use it. Fusion is difficult. Helium-3 fusion even more so. But breakthroughs are coming. And whoever learns to extract, refine, and ignite it owns the future of energy. So China is mapping it. The US is studying it. Private companies are writing proposals around it. And the moon is no longer just a destination. It's an engine. So where does this leave us? The moon is changing. Not physically. Its craters and dust remain untouched by time. But conceptually, it's no longer a cold gray orb in the sky. It's a frontier with stakes, strategy, and secrets. Its far side is being explored. Its poles are being claimed. Its minerals are being weighed in kilotons, and its regolith analyzed for life-supporting compounds. And while the surface appears quiet, the forces beneath, political, economic, scientific, are in motion. Will this lead to international collaboration? A shared research station? Perhaps even a return to that spirit of unity that once defined the ISS? Or will we see rivalry take hold, as nations build side by side, but separately, eyeing the same resources under the same eternal sky? No one knows yet, but the moon knows, because it's watched us once before, and it will again. The moon was silent for decades. Now it echoes with ambition. We're going back, not just to visit, but to stay. If you believe the future won't be written on Earth alone, hit subscribe to stay ahead of what's unfolding in real time. Drop a like if this story helped connect the dots. And leave a comment. Should the moon be open to all, or protected from us entirely? Because above our heads, a quiet race is unfolding. And this time, it's not about planting a flag. It's about who gets to keep it flying.